Okay, so when we solve these, the logarithmic functions associated with this recording, we're going to have to apply some properties of logarithms. And they look a little different sometimes because they have logs on both sides. So here we have 1/2 of log base 3 of x equals 2 log base of 3, 2. So before we can do anything, what we need to do is get any coefficients. We need to get those up into the exponent spot. So in some of the other videos, we took exponents out of the exponent spot and put them down in front, and here we're putting them back. So we get log 3 of x to the 1/2 equals log 3, 2 squared. And so now I can raise each side to the 3rd power, and I get x to the 1/2 equals 4. Now to solve for x, I square both sides, and that's going to cancel the 1/2, and I get x equals 16. So here I get 2 log base 5 of x equals 3 log base 5 of 4. So both cases, I need to move that exponent up into the, or the coefficient up into the exponent spot. So I get log base 5 of x equals log base 5 of 4 cubed. So I take each side and raise it to the 5th power, so 5 to the log base 5, oh, lost the squared, equals x squared equals 64, because that's 4 cubed. Take the square root of both sides, and we get x equals plus or minus the square root of 64, which is plus or minus 8. But I look up here, and I can't use a negative number in that spot. So x can't be negative. So we get x equals 8. Let's look here at log x plus log x plus 15 equals 2. So the properties of logs say that I can rewrite this sum as a product. So 2 logs with a sum becomes the product of log of x times x plus 15 equals 2. And now this is log, the common log, which is base 10. And so I get x squared, or well, I get x times x plus 15 equals 100. This is a quadratic. I solve it by expanding. And then subtracting the 100, getting everything on one side. Now this may factor. And I got to figure out what it might factor into. So factors of 100 are 10 and 10, which does not add up to 15. We got 25 and 4, again, does not add up to 15. But 20 and 5, so 20 times 5 is 100, and when you subtract, you get 15. So let's do 20 times 5, so new page. X squared plus 15x minus 100 equals 0. So I get x plus 20, x minus 5. So x plus 20 equals 0, x minus 5 equals 0. Subtract 20 over here. Add 5. And so now I need to go back. I can't use a negative number, so this 20 is out, and my solution is x equals 5. Here we have one that is log 8 of x plus 6 equals 1 minus log 8 of x plus 4. Now, I have some choices. I could move this log over to the other side. But I think what I'm going to do is rewrite this. Yeah, that's what I'm going to do. I'm going to add that to both sides. There are other ways to do it. Okay, and what I get is log 8 x plus 6 plus log 8 x plus 4 equals 1. Rewrite this as 1 log. Oh, and now raise both sides to the 8th power. So that cancels, and I get x plus 6 times x plus 4 equals 8. So I need to expand here. So I get x squared plus 10x plus 24 equals 8. Subtract 8 from both sides. Again, it's a quadratic, so 16. And so 16 has factors 8 and 2, which add up to 10. X plus 8, x plus 2. So x equals minus 8 and x equals minus 2. Let's go back to the other side here. If x is minus 2, I'm going to get plus 4 and plus 2, so that's okay. But if I use minus 8, I'm going to get a negative here and a negative there. So x can't be negative 8 because I'll take the log of a negative. So my only solution is x equals minus 2. So I think that is what I wanted to show you for this video.